So welcome everyone to the last session of the day. I hope you're not too tired. My name is Isabel Huerga. I am a technical account manager at AWS. For those of you who are not familiar with enterprise support or TAMs at AWS, we often get engaged when customers have already built their environments, so we either help them with their struggles or we work together with them to continuously improve and expand those environments. So I hope I can give you some advantage here today. And if you're in this session, you probably want to learn more about building a modern data platform in AWS. If not, you might want to check if you're in the right theater. But we're going to discuss some of the core components to build a modern data platform and to perform some of the most common types of analytics. So we hear from companies all the time that they want to extract more value from their data, but they struggle to capture, store, and analyze all the data they generate. Traditional silos weren't built to work well together and make it difficult to consolidate data and to perform comprehensive and efficient analysis. Today's business applications and operational processes need to access data in real time. And we have different users with very different requirements. Do I have any data developers in the room? Some. Data scientists? Some. Business analysts? Builders? Cloud unicorns? Oh, a lot of those, OK. That was unexpected. OK, well, welcome, everyone. So of course, all of you want to use your own choice of tools and frameworks, right? So how do we build a data platform that can address all these requirements? A data platform that can go beyond insights, from operational reporting on historical data to being able to perform machine learning and real-time analytics to accurately predict future outcomes. At a high level, these are the main components. So let's start with the data warehouse. A data warehouse is a database that is optimized to analyze relational data. Data structure and schema have been defined in advance to optimize for fast, complex SQL queries. Data has been cleaned, enriched, transformed, so it can act as that single source of truth for data that your users can trust. Now, the other component is the data lake. A data lake is a single centralized repository where you can store structured, semi-structured, and unstructured data at any scale. And you can store your data without any preliminary processing or transformation. You can then process it in place and perform different types of analytics on top. Business intelligence, real-time analytics, machine learning, big data processing, you name it. Now, the main challenge with a data lake is that raw data is stored with no oversight of its content. For a data lake to make data usable, it needs defined mechanisms to catalog and secure the data. Without these elements, data cannot be found or trusted. And that's how a data lake ends up becoming a data swamp. So in order to be able to respond to all your different user requirements, your data lake needs to have governance, semantic consistency, and access controls. AWS provides a variety of building blocks that you can use a secure and flexible data platform. There are managed services that you can use to collect, store, process, find, and analyze structured and unstructured data in many different ways. So these are the services, right? Redshift, Glue, Athena. These are just some of the services. There are many, many more. So to see them all, it's going to take about 4 hours. I hope you're comfortable. Now we're going to just see some of the main components to build the data lake infrastructure and to perform different types of analytics on top. Right, so let's start with where data is stored and how can you organize, manage, and prepare it for analytics. S3, of course, is the optimal foundation for a data lake because of its virtually unlimited scalability and performance. It allows you to decouple or to provision storage and compute independently, so you can scale as you need and in a cost-efficient manner. S3 is that single centralized repository where you can store data in its native format without any transformation, any schema definitions. Now, for security, it provides different options for encryption, both at rest and in transit, including across regions. You can configure and enforce access controls and security policies, not only at the bucket level, but also at the object level. With CloudTrail data events, you can audit how, when, and who is accessing individual objects in S3. It also provides a daily inventory report where you can see a list with all of the objects in your bucket with important details like its encryption status. Another tool that you can use is S3 storage class analysis. It allows you to monitor the access patterns across all the objects in the data lake and to identify opportunities to move data to lower cost storage tiers, for example, in frequent access or even Glacier. And you can use this information to create an S3 lifecycle policy to make that data transfer across tiers automatically. And for those access patterns unknown or access patterns that change, you can also use the S3 intelligent tiering storage class. So, AWS Glue. AWS Glue is a fully managed extract, transform, and load service. And it allows you to catalog your data and clean it, enrich it, and move it reliably across data stores. So the Glue data catalog will store metadata about your data sources, your transformations, and your targets. It's a drop-in replacement for a Hive metastore. And it also provides the job system, so you can define, schedule, and run ETL operations. So the Glue crawlers will scan the data, infer the schema, and construct the data catalog. These crawlers will use built-in classifiers for known formats like CSV, JSON, and columnar formats like Parquet. But you can also use your own classifiers or take them from the AWS Glue community for other data formats, or if you want to customize the tables. Glue will use the metadata in the data catalog to automatically generate scripts in Scala and PySpark that you can use to and modify for different ETL operations. So for example, you can extract, clean, and transform raw data and store the results in a different repository where you can query and analyze it. So let's say you're landing CSV files. You can transform them into a relational form and save the data in Redshift. And you can automate those scripts with jobs based on a schedule, chaining them, or even triggered by events. For example, every time new data arrives in the data lake. So there are a lot of steps involved in building a data lake. Let's start. So we have to set up the storage. We talk about S3, so you have to set up the buckets and partitions. You have to then move the data, so from all your different sources. You then have to clean and prepare the data. So for example, removing duplicates or, again, transforming to a columnar format, for example, Parquet, that will optimize performance. And of course, you have to catalog the data. Now, data needs to be secure based on your different compliance requirements, and access restricted based on those requirements. And finally, you have to make data available to the different people in your organization. So you have to label the data in the catalog and make it accessible to users. Okay. So as you can see, this takes a lot of time because a lot of this is done manually. A fully productive data lake can take months to implement. And that's why we announced AWS Lake Formation in the last reInvent. So as Andy just said during the keynote, while you can set up your data lake manually, the work it takes to set it up, unload the data, and set up security can take a lot of time. So Lake Formation will simplify this manual process by automating many of these steps. So you can build your data lake with just a few clicks from a dashboard. You have to specify where your data resides and what access and security policies you want to apply. Lake Formation will collect the data from your database and your databases and your object storage. It will load it into your new S3 data lake, It will clean and classify data using machine learning algorithms. It will then secure access to sensitive data. And finally, your users can access a centralized data catalog that will describe all the available data sets and its relevant usage. Easy, right? So if you want to check the preview, just go to that URL. Moving on. So we have the data stored, it's secured, it's cataloged, so it's ready for analysis. And here's where the fun begins. Let's start. For operational reporting, for operational analytics, like for example, application monitoring or clickstream analysis or log analysis, Amazon Elasticsearch Service allows you to search and filter and aggregate and visualize data in near real time. It's a fully managed service, so it will provision all the resources for your Elasticsearch domain, and it will also automatically detect and replace any failed nodes. It provides built-in integration with ingestion tools like Logstash and visualization tools like Kibana. And it also supports the Elasticsearch open source API. So if you're already using Elasticsearch in your environments, you can continue to use your own code and applications. So real-time analytics. Kinesis allows you to collect, process, and analyze streams of data. So we're talking about telemetry data from IoT devices, or website click streams, or application and infrastructure logs. It analyzes data as it arrives in the data lake, and it allows you to respond in real time. It provides many advantages, right? We've talked about it accelerates intake because you don't have to batch data before you submit. But also, if you're using it for application logs, it prevents data logs if, for example, one of the application servers fails. And it also helps you reduce that local storage in those producers. Kinesis is serverless. So you just have to point at an incoming data stream and specify where you want to store the results. Kinesis, and obviously you have to also write the queries, or you can use the available templates. Kinesis will take care of continuously running those queries while data is in transit and sending the results to the destinations. So for interactive analysis, Athena allows you to query data directly from the S3 data lake using standard SQL queries. Athena is serverless, so again, no infrastructure to set up or manage. Athena allows you to run ad hoc queries against the data sets in S3 without having to move data or load it into a different analytics platform. It can process structured and unstructured data because it supports formats like CSV and JSON, and also columnar formats like Parquet and ORC. Athena also provides integration with tools like Amazon QuickSight. For those of you who are not familiar with QuickSight, it's the AWS tool for business intelligence, so to create visualization and dashboards. But you can also use your own BI tools if you prefer, using the JDBC driver. So big data processing with the Apache Spark and Hadoop ecosystem. So EMR uses Hadoop to send data, to distribute the data across an elastic cluster of EC2 instances. It's a fully managed service, so it will provision and maintain the infrastructure and the software of the Hadoop cluster for you. With EMR, when you set up your EMR cluster or your job flow, you can specify how many and what type of EC2 instances you want to provision. And that includes reserve instances and spot instances for a lower cost. You can also set up a permanent cluster that stays up all the time, or a temporary cluster that will terminate after the job is complete. EMR provides a lot of flexibility. It supports many, many frameworks like Spark, HBase, Presto, Flink, and it also can access data from other data stores like Amazon S3 and Amazon DynamoDB. If you're using notebooks, EMR allows you to create applications and collaborate in a managed environment based on the Jupyter notebooks. So let's move on. And we're back to the data warehouse. So for data warehousing, Redshift allows you to execute complex analytic queries against petabytes of structured data. Redshift uses machine learning, a massive parallel architecture, compute-optimized store hardware, and subset result caching to provide high throughput and sub-second response times, even when you have thousands of concurrent users on queries. With Redshift, you have full control of your queries and your queues. You can use WLM, workload management, to add more queues and specify how the queries are routed to these queues. And you can use QMR, query management rules, to create rules with specific conditions and actions for each one of those queues. So for example, you might want to log all the queries that are using nested loops to identify opportunities to improve your user syntax. Or you might want to consider hopping or even aborting queries that run for more than a specified time in a specific queue to keep that queue going. And for burst of demand, for those peak times when the number of concurrent queries increases, Redshift now provides concurrency scaling. So it allows you to deal with these peak of demands without having to continuously predict capacity or without having to over-provision that data warehouse cluster, right? It will add more processing power just when you need it, in seconds, and in a transparent manner. Now, Redshift is complemented with Redshift Spectrum. Redshift Spectrum allows you to query data directly from the S3 data lake. But you saw that with Athena. Hey, thank you, you've been paying attention. So yes, but with a Spectrum, you can have the hot data in the Redshift cluster where it can benefit from the performance of the local drives and use a Spectrum to query the cold data in the S3 data lake. And you can have queries that span both the frequently accessed data in Redshift and the full available data sets in the S3 data lake. So it provides virtually unlimited scalability, and without having to move data to the data warehouse, or without having to scale up the data warehouse just to have more storage. Remember that with Spectrum, you pay for the data process to execute your queries. So you might want to consider using columnar formats like Parquet, which not only will optimize performance, but also reduce cost. So we've seen a lot of building blocks that you can use to create that data platform and that you can use to respond to very different user requirements, and including requirements that keep appearing, right, with new user needs. It's important that also you leverage that flexibility and automation. We continuously improve and provide new features. For example, Redshift recently announced automatic WLM. So make sure you keep including and evolving those data platforms. Governance. As we said, we're here to build data lakes, not data swamps. So make sure you know what data is in the data lake and who can access that data. And finally, I don't know if I've mentioned this today, but you might want to consider using columnar formats like Parquet that will optimize performance. So we've seen all these building blocks. Now let's hear how Paddy-powered Betfair has been using and combining all these building blocks to build a data platform that has continuously grown and evolved with their business. To tell us more, we have Stephen Cochrane, Director of Data, and Oana Jakovica, Head of Data Delivery from Paddy-powered Betfair.
Good afternoon. So I'd like to introduce our organization and provide a bit of context for the journey we've been on for the last 2 to 3 years to build our modern data platform. And then my colleague Oana will talk through that journey and share some lessons we've learned from implementing these various building blocks. So Paddy-powered Betfair was formed in 2016 when the two organizations merged. And that created one of the largest sports betting and gaming operators in the globe. We've 8,000 employees located in offices across Europe, the United States, and Australia. So we operate 6 brands globally, and each of those brands is focused on a particular market, or where there's overlap, those brands are focused on particular customer segments within those markets. We offer a mix of sportsbook, gaming, exchange, and daily fantasy sports products across those markets, and we deliver those through a range of online and retail channels. So we're a data-rich organization, and this creates serious demand for our data services. So in 2018, we had over 6 million active customers worldwide, and those customers generated over 80 billion in traded transactions across all those platforms, with our biggest payout being 4.5 million on the World Cup final last year. A couple more numbers. In online, we had over 3 billion transactions, and that's quite spiky. It's not consistent, so we've peaks and troughs depending on the sporting events. One of our highest traded events was the Melbourne Cup with 35 million pounds. So when we merged, we needed to transform our data capability. Both Paddy and Betfair individually had quite mature on-premise data platforms, but following the merger, that created a challenge that we now had essentially two silos, where we had two sets of data models, two sets of subtly different KPIs and metrics, and it meant that our business really found it difficult to measure performance. So we then had a challenge to really rapidly build out a new platform that could service both Paddy and Betfair brands consistently on a single platform. So both organizations pre-merger were working with cloud providers while being predominantly still on-premise. But our strategy was very much to move to a fully public cloud-hosted solution for data and analytics. So while the merger created a great challenge for us, it was also a great opportunity to rapidly accelerate that migration from an on-premise organization to a fully public cloud-hosted platform. So with that context, I'm going to hand over to Juana now to talk through the actual journey.
Thanks, Stephen. Like Stephen mentioned, 2016 was a great opportunity for us with the merger of Paddy Power and Betfair. And from then on, we started our journey to bring the two on-premise data sets together into a modern data platform in AWS. So I'll walk you through our steps, and we'll start with the middle of 2016. So AWS has been around in one of the heritage organizations, and we have had some early on proven business value with a first implementation in S3, Redshift, and in AWS EMR. And the proven business benefits were that log processing that took a lot of time to happen, so it took quite 1.5 days. It went down to about 20 minutes. And queries over these data sets went down with the help of EMR from hours to sub-minutes. So that was one of the very first use cases that helped build the trust and confidence in AWS as a whole. In 2016, we were already, as mentioned, using S3 and Redshift, and as we moved on, onboarding more and more data sets into this unified data set, we had to upgrade or upsize Redshift to now 14 DC1 nodes. In this strategic implementation, we weren't just moving into the AWS cloud, we were also onboarding other strategic technologies. So we started leveraging AWS KMS service for encryption purposes for our ETL tool, for our data integration tool, which is a third-party tool deployed to the cloud, as well leveraging EC2 instances. We knew from the very beginning we're going to be a large-scale operation in cloud, so we invested early on in full automation of our AWS account management, our AWS user management, and security. That was a very, very important thing. And for that, we've used a number of AWS services yet again. By the beginning of 2017, we were now at 30 terabytes of data in Redshift, about 19,000 daily queries, and about 290, give and take, active users. With this came another upsize to 20 DC1 nodes. So you can say from 2015, actually, when we had 4 nodes in Redshift, we were now at 20 nodes. So it's a pretty rapid increase there. At this point, we realized that obviously onboarding data sets, you can't just onboard data sets and just leave them there, hope for everything to go well. We are a 24/7 operation. We need to not only make the data available, but we need our platforms to be extremely stable, and we need them to be performant. So it's absolutely necessary for us to get ready and have a collaborative engagement with AWS support, and we've done a lot of work with Isabel here, to make sure that our processes, as far as issue resolution, escalations, is as fast as possible and as efficient as possible. So we've done that through governance of large-scale operation at the beginning of 2017, and we have reaped the benefits of that to date. So that's an advice that I can give you. Make sure you think about your operations early on in your process if you are moving to the cloud. As we moved on, we continued leveraging EC2 instances for further deployments of strategic tooling in our data architecture. In 2017 also, we realized that Redshift is not the answer to all the questions we had and all the use cases. So we took on the AWS RDS Postgre for our low latency requirements. This was one of the very first times that we were doing adding a new service and making sure that we are using the appropriate service for our use cases. So moving on to 2017, now we were almost there with all combined data sets. This was extremely important for us because, as you know, reporting of two separate data sets, of two separate data models, of two separate on-prem data warehouses does not really work in the real world, right? You need one data set that is able to be queried and analyzed and business decisions to be made on. So by this point, we were already having the majority of the data, and we've done probably our latest or last biggest upsize of Redshift to 28 nodes. And we continue to leverage AWS EC2 instances for additional strategic technologies that we've deployed to the cloud. In 2017, there was a game changer for us. So if the keynote speaker mentioned this earlier today, that Redshift has improved in the past 2 years 10 times, I'm the first who can confirm that. I've been there on the journey, and I have seen that improvement surface. And one of the reason I mention this now is because the node type of DC2 launch was the breaking point for us. At this point, with the node type change, we have seen an uptake, a significant increase of the usage of our platform. We were now at 62 terabytes of data. We had about 439 active users, and at about 30,000 daily queries versus the 19,000 you were seeing earlier. Obviously, with onboarding more data, we are now moving into new capabilities. So we have built our in-house streaming data streaming processing framework with the help of AWS services, namely the AWS SNS and SQS services. So we were seeing more and more S3 stream data out there. With 200 terabytes of data in S3, it was now time to make sure that our S3 data lake data is being used and surfaced. So we are seeing the first implementation of AWS Spectrum in combination with the Redshift we're already using for some productionized workloads and use cases. Aurora came out in 2018, and we jumped right in. We evaluated the bells and whistles that AWS Aurora came out with and realized that's something we want to adopt and replace the early on AWS Postgre RDS database that we had in place. So at this point, it was another important moment for us where we've upgraded basically from the older version to AWS Aurora. Automation has been a very important trend for us throughout our journey, and at this point, we started investing more and more into making sure that we use all sorts of AWS services for automation and operations to automate as much as possible. So I know AWS Lambda, for example, has been a topic. Everybody's talking about it. We've been using it for quite a while, and our data operations, data DevOps, what we call them, are very, very much familiar with this technology and have made very many use cases of it. If A year before, we focused a lot on making sure our operations are up to speed and they're as good, as great as they can be. It was now time to establish some ways of working with the product teams. And this is because we are pushing AWS a lot. We have very complex use cases, and our use cases a lot of the times translate into feature requests that we are happily to collaborate with AWS to build, and specifically in AWS Redshift and Amazon Spectrum. So we have established some very good governance and ways of working with the product teams to make sure that our requirements and our unique requirements translate into features on their product roadmap. So moving into 2018, we were now with our combined data set there. We started having streams data. A lot of automation took place. It was time for us to make use of our data, our combined data sets. So in mid-2018, we're seeing first implementations of AWS SageMaker for advanced analytics capabilities and ML models. As mentioned, automation remains at the forefront of this. Spinning up and down instances is extremely important for us, and not only spinning up and down instances for cost management, but also for the peak periods that Stephen were talking about. Additionally, it is extremely important, as you know, to be able to deploy configurations and spin up EC2 instances, but not only spin them up, also install what you need to install on there in a quick fashion. So we can say that we've invested a lot in infrastructure as code. CloudFormation is very important to that for us, and we are able to do that today. Using the in-house built streaming processing framework, we made use of AWS Kinesis and have implemented that for very, very extremely low latency requirements. So our AWS Kinesis implementation goes from transaction, so from something happening, to an operational alert being received in a sub-minute fashion because of this in-flight streams query possibility. I was telling you guys about advanced analytics use cases. This is very important to us and will continue to be important for us, like a lot of people in this room, I assume. We are making use of AWS DynamoDB right now and DAX for ML pipelines, alongside additional EC2 instances being spun up for additional strategic. We are looking and are implementing already automated deployments of applications. Finally, where we are today, we are continuing to make sure that our AWS account management and account governance is up to par. And this goes from security management to making sure that we operate lean, making sure that our cost is optimized for the different services we use, and basically making sure that our workloads are matched to the appropriate AWS service. We constantly analyze that to make sure that Redshift, the use cases we have on Redshift are appropriate for Redshift. The use cases we have on Aurora are appropriate for Aurora, and so on with all the other services. At this point, we are continuing to evaluate new technologies. AWS are continuing to release new technologies, and we want to make sure that we are staying front and central with that to not miss the opportunity. So right now, we are onboarding Glue capabilities as a substitute to the early on EMR, which is still present and functioning. And we are exploring Athena capabilities for our potential use cases. Lastly but not least, while we continue to onboard new technologies, we want to do that building on the lessons we've learned and making sure that we don't forget about all the other technologies that are now mature. So we are continuing to focus on operational excellence and continuously improving the AWS services we've initially onboarded. So what are the AWS benefits that we've seen in our journey? And this has been a 2.5-year journey, and there's been a lot of day ones in that. Let me tell you that. The keynote mentioned day one. We had a lot of day ones, and I think you just need to expect that that's going to be the case for your journey as well. So you can probably relate to some of these. I'll tell you the Paddy powered Betfair version of it. AWS has been scalable, and this was extremely important. I already mentioned this. We started with a 5-node cluster. We are now at 30-node clusters in Redshift. Athena, Aurora, and all the other services are scalable. It is extremely important because AWS helped us and walked the journey with us. So rather than us trying to predict where we should be in 2 years' time and how much capacity we should have for an on-prem data store, we were able to grow as our needs grew. AWS proved to be very varied and very flexible, and this is extremely important for a mixed workload. If we could not fit the requirements that we had for AWS Kinesis, for example, on something like AWS Redshift. They're completely separate technologies meant for completely different purposes. So the fact that we had options, it was extremely, extremely important for us. 24/7 operation, we cannot afford to lose or be down for minutes. Not even minutes. It's not acceptable in our world. So having a provider that has operational support and focus on continuous improvement was extremely important. And this is where the work with AWS support, including Isabel, came into play. And another item very important to us, we have a large data engineering and data automation developer base. And for the complex work items we have, they need to be very, very proficient. So we need readily available information and readily available knowledge for them to get up to speed and then become the experts in the room. So, and that has been the case with AWS. And just to give you guys some insight, we've been on calls with AWS support, and AWS engineers have been extremely supportive with making sure that they share the knowledge with our developers and our engineers, and we become self-sufficient, which is the best thing you can get. Lastly but not least, AWS has been and is continuing to be very collaborative as far as extending the product for our unique requirements. The VLM QMR rules that AWS has released and Isabel was mentioning is something that we needed extremely bad, and is something that we collaboratively worked on to continue to improve. And that's just an example. So what have we learned? Well, we've learned a lot of things, but just to give you guys an idea of what we've seen throughout this journey. So as you've seen, there's a lot of benefits to using AWS, but obviously, AWS services are cutting-edge technology. They're newly released platforms, and with that comes some risk. You need to be aware that there will be risks that need to be mitigated together with AWS, and that has worked quite well for us. Another item is extremely important to match your workload to the appropriate AWS service. We've learned that the hard way, using Redshift for everything and realizing that's not appropriate. And that's the moment when we stepped up and looked at what is the use case and what is the AWS service. Adhering to the different best practices and understanding the different best practices for each of the AWS service is key. And more importantly, working with your stakeholders to make sure they understand it is even more important. If we had to do this all over again, we probably would have invested a little more early on the archiving and automation of the data itself, because we saw ourselves needing to do that quite late in the game. Just to make sure that we are using Redshift capacity or any other AWS service capacity appropriately. Another item is value of the new services. Moving from 2 large on-prem data sets on platforms that worked and did the job to brand newest technology in the cloud is not easy to swallow by your users. And we have hundreds of analysts and data scientists in our organization that need to move their reports, their dashboards, their workloads to the new platform. So with this, proving the value of the new services early on is going to help a lot with the adoption of the new platforms. And last, understanding the product roadmap is very, very important. It's very important to understand what's coming from AWS and what will be released, what's the time frame, and what you should invest internally in making it work by yourself. And this has been very important to us. So where we are and where are we going to do moving forward? We have a mature set of capabilities on our integrated data platform. We need to mature and fine-tune those, and we will continue to make sure that we use the appropriate AWS services for our loads. We will continue to assess new technologies and make sure that the new technologies are scrutinized and they are ready to be used for our use cases. We will continue focus on making use of the combined data sets for advanced analytics use cases, and the automation, operational excellence, and collaborative governance with our stakeholders is something that we're going to continuously do. So this is something that we will continue to do. Thank you so much for listening, and I'll pass it on to Isabel. Thank you.
Awesome. So I hope you can take to heart this advice, all these tips and recommendations that we have provided today. Use the building blocks, combine them, try them, find the ones that fit the right use case. I cannot stress how important and how much these recommendations are going to help you. So if you didn't take a picture, you'll be able to download these slides soon. So thank you so much for joining us. I hope you've enjoyed. Please remember to complete the survey. Give us your feedback. We really appreciate it. Thank you so much, and enjoy the rest of the evening.